This problem is a great training exercise on how to interpret the inverse tangent function and why you can't always trust your calculator. So to do this, I'm going to start off with this first point right here, 1 comma 5. Let's talk about 1 comma 5 for a second. You can understand that if you were to plot this on a graph, it would be somewhere in the first quadrant, like that. So first answer box is very easy. Next, what's the arctangent of y over x? So if you think about that, it's saying arctangent of y over x, that's 5 over 1. Okay, we can simplify that, easy enough. That's called the arctangent of 5. And if you want, though this is not necessary, you can go to your calculator and say, what's the inverse tangent or what's the arctangent of 5? And what you're going to get is like 78.7 degrees. Okay, that's not what it's asking for. It's just asking what quadrant is that in. And you can see that 78.7 degrees, if you were to imagine rotating from the positive x-axis, that would be something like this. So that's 78.7 degrees, and it looks like that's in quadrant 1. So now, with the last box of that row, the question is, do we need to adjust the arctangent 5 over 1 to make the calculator and our coordinate point agree in their location? And the answer is no, we don't. There's no adjustment necessary. They already agree they're at the same place. Now it's going to get a little more complicated with the next one. Let's try doing 2 comma negative 1. Okay, so for 2 comma negative 1, imagine drawing this thing. That's going to be 2 over 1 down. It's going to be like this. Okay, great. So what quadrant is that in? That is in quadrant 4. And what quadrant is the arctangent in? Well, if you do the arctan of y over x, you get arctan of negative 1/2, which again, I'll just use the calculator even though this is not really necessary. I'm going to get negative 26.57 degrees. Okay. Point is, it's in quadrant 4, and there's the angle. Okay, now that kind of makes sense because the angles in quadrant 4 are often said to be negative. So we're going to say this is in quadrant 4. Okay, that looks good. It's matching between the coordinate point and the angle. The problem here is, if you look at this question, it says, what do I need to add to make this a positive angle? And currently it's a negative angle. So to turn a negative angle into a positive angle, but without changing the actual location of that angle, we're going to add 2 pi. Okay, I'm sorry there's a little disagreement between degrees and radians here. It's actually not necessary to worry about degrees at all. We could have just ignored the actual number, 26.57, if we wanted. Let's do another one. Let's do that next one, which is negative 1 comma negative 5. And I think you'll see the pattern here. So first of all, if you were to imagine plotting this, I know that's going to be somewhere down here, right? Negative 1, negative 5. So that's going to be in quadrant 3 from the looks of it. And now if I say, well, what's the arctan of the y value, which is negative 5, divided by the x value, which is negative 1, you'd say, oh, well, that's the same as the arctan of 5. And we already did that before. That's 78.7 degrees. So whoopee, there's my angle right here, 78.7 degrees. And now we say, well, wait, hold on. There's a disagreement going on between the location of that coordinate point and what the calculator is telling me for the angle. The calculator is telling me this thing's in quadrant 1. But we know, because we're looking at the graph, that that coordinate point is really supposed to be in quadrant 3. So the question is, how do you move from quadrant 1 to quadrant 3? You have to add pi. Okay? And this is really getting at the heart of the whole discussion with what calculators tell you for the arctangent and whether you should trust it or not. It depends on the pluses and the minus signs. And the real reason for all this nonsense is you've got 2 choices here for the calculator's answer, quadrant 1 or quadrant 4. Even though there are 4 possible places these coordinate points could be, quadrants 1, 2, 3, or 4. Okay, so you have to manage that little disagreement with a plus pi. And then every now and then you have this little gimmick where you have to add 2 pi because you want a positive angle, not a negative angle.